Bismillahirrahmanirrahim. Assalamu alaikum everyone. We are H.A.S. Today we will simulate two circuits involving operational amplifier. First question is that what is an operational amplifier? An operational amplifier is a very high gain differential amplifier with high input impedance and low output impedance. Typical uses of operational amplifier is to provide voltage amplitude changes, that is magnitude, and as well as polarity. Other uses are oscillatory circuits, filter circuits, and many type of instrumentation circuits. An operational amplifier contains a large number of differential amplifier stages to achieve a high voltage gain. We can see here that the operational amplifier has two inputs and one output. I repeat that two inputs and one output. If the signal is applied at the positive input, or you can say at the plus input of the operational amplifier, the output will be amplified and will be in phase with that of the input. And if the input is applied at the negative terminal, that is the input signal is applied at the negative minus terminal, the output will be amplified and it will be 180 degree out of phase to that of the input signal. So what we are doing today is called as single-ended operation of operational amplifier or op-amp, which means that only one input of the given operational amplifier will be given input, whether it will be positive signal or negative signal, and the other input will be grounded, whether it will be positive or it will be negative. So in this panel you have two amplifiers, inverting and non-inverting. In non-inverting, the input is given on the positive terminal and its voltage gain is given by this formula. And in inverting amplifier, we gave input at the negative terminal and the gain is given by this formula. Here the negative sign shows that the output will be 180 degree out of phase to that of the input. What we see here, that this is the circuit of inverting operational amplifier, as input is given on negative terminal of operational amplifier or op-amp. So run PSpice. So as you see that green is the input and red is the output, and the red is totally out of phase to that of the input green. Alright, back to the circuit. Remove the voltage probes from here, that is the first, that is the second voltage probe, and place them here, that is the non-inverting operational amplifier. Use the voltage probes like this. Alright, we have two circuits in this one file. Now run PSpice. You can see that the green is input and the red is output, and green and red both are in phase with each other. Alright, you can see it from here, green is the input, red is the output. Now I am closing this window and I will make it again for you, that is no project. Name it whatever you like. I will name it H.A.M. Okay. Create a blank project. Okay. Now this window will appear. Now first of all you will edit the new simulation profile, that whatever name it, I will name it the same as my project name, H.A.M. Create. Now first thing we have to do is to pick our components. Go to library. The most important component of today's project is UA741 eval. place it here like this. This is our operational amplifier. Now we have to place our components, other components, that are the resistors. This is the first resistor, this is the second resistor. Now we have to place our plus VCC and minus VCC, that are the DC voltage. You may rotate it by clicking R. This is the plus, this is the minus, like this. Alright, now our AC source, passive, that is sources, voltage sources, that is input, but that will be sinusoidal input source. Now we have to join our all components like this, like this. In the operational amplifier here, that is US741, we won't use 5 and 1, 6 our output. 5 and 1 are voltage offsets, that's why we are not using them. We don't have to connect them to anything. So we have to place our PSpice ground to both DC voltage sources, like this and like this. You can rotate them by R. Now again place wire, input. But before joining it, I want to tell you something. I will connect it later. First, this is the circuit basic structure of our operational amplifier, and it will be used in both inverting and non-inverting amplifier. Now if we connect this positive terminal to the VCC, then it will be non-inverting, and if you will connect the voltage source to the negative terminal, then it will be inverting amplifier. So first we will make it as non-inverting amplifier. Place it like here. Now we need a ground, so it will be PSpice ground, like this, ground it. Alright, now simply we will value our whole components. It will be 12 volts, it will again 12 volts, this is the feedback resistor that is used. This is used to control the output, that is 22 kilo. Now R1, the value of this resistor will be 10 kilo. Now V offset, it will always be 0. V amplitude, its value will be 10 millivolt. Now frequency is usually 100 Hertz. We have created our simulation profile. We have to edit this. If this doesn't appear, you can edit it from here, that is edit simulation profile. Run to time will be 100 milliseconds and maximum step size will be 100 microseconds. Okay, now run PSpice. But before running, I forgot to use the voltage probes. So voltage markers, this one here for input and this one here for the output. Now run it, run PSpice. Now this window will appear. As you see, green is our input, red is our output, and both are in phase with each other. Alright, now to make it inverting amplifier, all we have to do is to delete some connections. Place wire. We will connect this, but I guess first we have to remove this ground. Now use place wire and connect this resistor to this positive voltage source. Now place this ground to the positive terminal. Now it will act as inverting amplifier. Place the voltage markers like this. Now see run PSpice. You can see that the red is our output, green is our input, and red is totally out of phase to that of our input. That's all today, and don't forget to subscribe our channel. Thank you very much.
Guys, don't forget to subscribe down below, and also give this video a big thumbs up, and don't forget to comment down below. The dark.